Hello, this is now part 3 of voltage synthesis basics, or I should say voltage synthesizer basics. Now, this video I'll be showing you my crude working prototype. But first I need to talk about a few things first here before we start. Now, this is not frequency synthesis, or like they use in music, where they synthesize just about any sound they want. And that is a lot more complicated than my idea, voltage synthesizing. And that's what's great about this is it's so much more simpler. Now, do you think I know what I'm talking about? Or should I say, do I think I know what I'm talking about? Well, yes and no, because I've been learning things as I go along with this. And I've made a couple errors just in the last couple of videos. Well, the first one is in diagram 3 that I showed you. Okay, and I need to show you this again because this is how I wired up my prototype according to diagram 3. Now, there's an error in diagram 3, and I'll show you that to you right now. First, in the video part 2, when I talked about this, I forgot to go through the pathway that goes through the transformer. I did the one up here, the AB branch. Now, there's a problem with this diagram, but I talk about it in my publication with WePo. Now, the connections to C and D are wrong, okay? The connection C should actually go to J, and the connection D should be connected to B, okay? And when you just draw it out yourself, and then you can go through the pathway of the current, and it makes a lot more sense. Actually, it works, but one of these ways it doesn't work if you use this drawing here. Now I'll be drawing the correct picture of this and show this in a later video, and we'll go through it again. Now, I'll be showing you a picture of a transformer too in this diagram, and I'll explain why that connection is wrong. And the problem is the engineers will look at this, transformer engineers, and will know it's wrong. And they'll say, oh, that won't work, okay? But I explained that in my publication with WePo, published on May 16th, and hopefully they read that and they'll understand that. Because this is actually going to be 180 degrees out of phase with that, if you wire it up exactly like that. And I didn't know that part about that. Okay, what else did I want to say about that? Oh, also in the same video, part 2, I made an error talking about the speed of electricity. And I said that the wavelength of a 60 hertz cycle, 60 hertz signal, I said it was 5 meters long. And I said that 5,000 meters was wrong. But I'm the one wrong about that. I did my calculations, and it is 5,000 meters, okay, if you use the speed of electricity. So if you go to my comments just below the video, you'll see that I wrote that in there. And also the link to my publication is in there also. And these diagrams are drawn with an app, and you can find this app at digikey.ca. It's digikey.ca. digikey.ca, and you can try it out for free. But you're not supposed to use it. You have to pay them if you want to use it. Okay, Got to put this on pause and I'll be right back. Oh, it doesn't pause for some reason. Oh, I see, that's why. Because it's telling me my battery is low and it won't pause during that. Okay, here is a picture of an isolation transformer, 1-to-1 ratio, that I'm going to be purchasing pretty soon. It's the new ones by Hammond, and they're about $142 or $147 or something like that. And that would be that's in Canadian funds too. And you can see it's got a switch on the top. That's the breaker switch. That's on the primary side. And you can see they got 3-prong plugs on them. And the neutral wire prong is a little wider than the prong for the hot wire. And that's just for safety. But I'll be talking about that when I show you my prototype a little bit. Okay, now the schematic. Well, it says the top here is 500 VA. So with a power factor of 1, that means it's capable of supplying 500 watts of power. Now, I thought they'd be good for 1500 watt heaters, but no, they're probably not good for 500 watt heaters. But there's a way to get around that to do more with it. Now, there's a schematic at the bottom. Now, you can see that those prongs for the hot wire and neutral wire are a little wider. And oh, I got to pause it again here because I shouldn't be doing this when my battery is low. No, I don't have to pause it. I just got to click off that warning sign. And okay, now we got to talk about where this hot wire goes. Okay. Now this is a hot wire. There's the hot wire right there. Now I think that's the primary side. Oh, excuse me. This is the primary side here because that's the breaker switch up there. Unless, yeah, okay, that's where you plug it in, so that's the primary. And that's the switch there. So this must be the primary side here. And that's the hot wire there, the narrower one. And it goes down here to the bottom of this transformer and goes up. But on this side, the hot wire is over here and it starts here at the top of the transformer. When over here it starts at the bottom. So there could be something like 180 degrees out of phase relationship here. I'm not a transformer engineer, so I don't exactly know how these things work. But that's why my diagram 3 is drawn correctly. And you just have to change the leads to get them in phase, to get them in phase with the other parallel branch that I made in diagram 3. So that's the problem. So I thought I'd just mention that. So I'm really learning things here as I go along, which is really good. Okay, I'll pause it now, and I'm going to go downstairs to my workbench and prepare to show you my prototype. I don't need any water. Okay, we'll go down, get to work on it. Plug it in right away and get to work on it. Hopefully it won't close.